Today we will see the example 2.4 of Griffith third edition Introduction to Quantum Mechanics. The example 2.4 is find the first excited state of the harmonic oscillator. Before going into the problem, we will see the creation operator. That is, A dagger by definition is equal to x over square root of 2h cross over m omega minus I p over square root of 2h cross m omega. Here, what I am going to do is you bring this m omega, square root of m omega, which is in the denominator. In denominator, you have so it will go to the numerator as square root of m omega. Now you take this outside, that is 1 over square root of 2 h cross m omega. So naturally, in the first term, you have to divide and multiply by square root of m omega. So this will become m omega x minus this one. This you can take I and p you replace by its operator minus I h cross t by dx. I am replacing p by its operator. So here, if you multiply minus I into minus I, you will get I squared. I squared is minus, you will get minus, and you have this h cross and t by dx. Now our ultimate aim is we want to find the first excited state. If rising operator, increasing operator or creation operator act on psi naught, it will produce naturally the psi 1. Now we are taking A1, which is the normalization, multiplicative factor of the normalization, first normalization of energy state to psi 1. So this will become A1 and this multiplicative factor. We have shown already that this is the normalization constant. M omega over pi h cross 1 over 4 is a normalization constant per ground state. And you have to multiply it by multiplicative factor A1 and you have A dagger this exponential term. We will simplify this. So we got this relation psi 1 is equal to A1 m omega over pi h cross whole power 1 over 2 and A dagger this exponential term. Now you replace A dagger by its operator, creation operator by definition, this one, which I have shown in yellow color font. So you take replace A dagger by 1 over square root of 2 h cross m omega whole thing multiplied by m omega minus h cross t by tx, then this exponential term. Here you have exponential term. Now you bring exponential term inside, then you will get m omega x, this exponential term. Here you remember that you are going to differentiate with respect to x. If you differentiate this exponential term with respect to x, then you will get there is minus. So minus m omega over 2h cross, and if you differentiate this x squared, you will get 2x. Then this 2 will get cancelled and you will get minus of minus will become plus. Plus m omega x, this h cross will get cancelled with h cross in the denominator, and you, of course you have x and the exponential term. Here you have same term repeated twice. So we can write this as 2m omega x, of course, 2m omega x. Then this exponential term, you will get this exponential term is constant and x also is a constant. M omega plus m omega, you will get 2m omega. Now we will simplify it further. Now we got this relation. Here we can simplify this. That is, you have 2 square root of 2 m omega, which will get cancelled with 2 m omega. This will become square root of 2 m omega because we are dividing by square root of 2 m omega. Only term left out in the denominator is h cross. So you can rewrite this as square root of 2 m omega over h cross and keep other thing same. This exponential term. Here you have A1 and this normalization constant for ground state energy level. So the term inside the rectangular box, that is rectangular red color box, is psi 1. So we got the psi 1. Only thing is we have to find the value of A1 normalization constant for excited state. Yeah. So here, in order to find the normalization constant, this equation must satisfy the condition that modulus psi 1 square must be equal to 1. If you square this, a1 squared, and this if you square the m omega over pi h cross whole power of this will when square it you will get half, and if you square this 2m square root will get removed, you will get 2m omega over h cross, and this we are going to integrate this because we have to integrate psi 1 star sorry modulus psi 1 square. So we have taken all constant outside, only the variable x squared and this square of this exponential term. If you take square of this exponential term, you will get e power minus m omega over h cross x squared dx must be equal to 1. So we have to find the A1 and substitute here. That is the psi 1 in psi 1. So we will get the psi 1 normalized wave function of first excited state. Now we got this relation. Our ultimate aim is we have to find this A1. Now we have to carry out this integral. This is exactly looks like a gamma integration. Sorry, Gaussian integration. So that is if integral is Gaussian form, that is integral between minus infinite to plus infinite, x squared e power minus alpha x squared dx is equal to 1 over 2 square root of pi alpha power minus 3 by 2. So this is alpha. Remember that m omega over h cross is at alpha. So now you take a1 square as it is and this term as it is and 2m omega over h cross as it is. Then replace this integral 1 over 2 square root of pi alpha power minus 3 by 2. Alpha is m omega over h cross power 3 over 2. Then here you can cancel out some of the term. You can cancel first this pi will get cancelled with square root of pi will get cancelled with this square root of pi. Here similarly this 2 will get cancelled with this 2. So remaining thing is if you multiply first two parameter, here m omega over h cross power of this is m omega over h cross. So this will become m omega over h cross power 3 by 2 plus 3 by 2. Here you have m omega over h cross minus 3 by 2. So if you multiply both, you will get 1. Then a1 squared is equal to 1. Luckily, a1 is equal to 1. So the first excited state, wave function for first excited state is this one, which we have seen some time back. So here A1 is 1. So naturally, the excited state wave function psi1 is equal to square root of, m omega over pi h cross power 1 over 4 and square root of 2 m omega over h cross x e power minus m omega over 2 h cross x square. This is the first excited wave function of first excited state. If you find this video useful one, then subscribe it. Kindly share it and join my channel for the growth of my channel. Thank you very much for continuously watching my video and supporting me continuously. Thank you very much.